Good morning. This recording is for Algebra 1, Chapter 7, Lesson 5, Dividing Properties of Exponents. Dividing powers of exponents with the same base, you just subtract the exponents. Nothing fancy, just remember that if there's a division bar, it acts like subtraction when it's applying to the exponents of bases that are the same. Again, the big number has to be the same if you're going to subtract the exponents. So here's an example. Z to the 10th over Z to the 5th. The reason the subtraction works, because if I write Z to the 10th in expanded form, that's 10 Z's divided by 5 Z's, and if I cancel out the same that I have on the top and the bottom, I am left with only 5 Z's. Well, again, the fast way to do this would be to be like, all right, well, I've got 10 Z's divided by 5 Z's. Well, that's the same as Z to the 10th minus the 5th, which is Z to the 5th. So again, you don't have to write things out in expanded form as long as you can subtract the exponents of the bases that are the same. All right? And remember, it's the top exponent minus the bottom one. It is always this. Don't try to switch it because otherwise your math's going to come out wrong. And again, if you have a double negative, basically subtracting a negative, it's going to become positive. And I'll have an example of that in just a minute. All right, so example number 2 works the same for both negative exponents. So if I have m to the negative first times n to the second over m to the fourth times n, I'm going to end up with m to the negative 1 minus 4 and n to the second minus 1. All right, and again, this is the whole negative thing. You can add the opposite, and it's going to be m to the negative first plus negative 4 times n to the second minus 1, m to the negative fifth times n to the first, because 2 minus 1 is 1. Negative 1 plus negative 4 is negative 5. And again, for now, since dividing by 0 is undefined, we're going to assume that no base is equal to 0 for right now. Again, later on in other math classes, they'll want you to do that, but for right now, we'll just assume that no base is 0. Okay. And again, this one right here is the more simplified version because it has positive exponents. This one is technically still correct, but we consider this one more simplified. All right, when we're dividing scientific notation, divide the first factors, then divide, not decide, divide. Gotta love spelling errors. The second factor, which is again the power of 10. So the first factors here are the 7.5 and 2.5. So we're going to go ahead and divide those, which equals 3. And then we're going to divide the powers of 10, which is 10 to the 12th over 10 to the negative 4th, which means subtraction. 10 to the 12th minus negative 4 is going to be, remember guys, this is add the opposite, so the subtraction sign turns into a plus, the negative 4 turns into the opposite, so that's going to end up being 10 to the 16th. And then just combine the factors again. So it's going to be 3 times 10 to the 16th. Pretty easy, cheesy, lemon squeezy. All right, we're halfway through. All right, division properties with word problems. In 2000, the total amount of this is supposed to be glass. Glass recycling in the United States was 2.7 million tons. The population of the United States in 2000 was 281.4 million. On average, about how many tons of glass were recycled per person? Write in scientific notation. All right, I apologize for all the typos. It's been a very crazy day, and it's barely 8 o'clock. All right, number of tons divided by number of people. So 2.7 times 10 to the 6th. It's 10 to the 6th because 10 to the 6th power is million. All right, divided by the number of people, which is 281.4 times 10 to the 6th power. Now, you could go through the crazy process of putting this in correct scientific notation first, or you can just go ahead and do the division and know that this is going to cancel out. All right, because 10 to the 6th divided by 10 to the 6th is 1. But I'll show that to you real quick. All right, so I'm going to divide, and I'm going to get 2.7 divided by 281.4 is going to be 0.00959488827. Now, and then put that into correct scientific notation. Since it was small and tiny, when you move the decimal place, it's going to have a negative exponent. So it's going to be 9.59488827 times 10 to the negative third. And then, since the second factor equals 1, the 10 to the 6th over 10 to the 6th is 1, multiplying by 1 just means that it is 9.3948827 times 10 to the negative third tons of trash per person, which is not not a lot. A ton is a lot, but you only have 0.009 of it. So that's actually not a lot. It's not like each person recycled a ton, literally a ton of glass in 1 year. All right, last slide, I promise. Raising a quotient to a power. So if we have 3 over x to the second gets applied to everything in the parentheses. So the 3 gets it, and the 2 to the second gets it. So it's going to be 3 to the second over x to the second. And remember, when you're raising a power to a power, you're going to multiply the exponents. This is the same thing that we talked about 2 or 3 videos ago. It was in this chapter, so go back and look at it if this is not making any sense to you. So again, that's 3 to the second, and 2 times 2 is 4, so it's 9 over x to the fourth. All right, last thing we need to talk about is raising a quotient to a negative power. When you have anything to a negative power, it becomes flipped. It goes to the other side of the fraction bar. The thing is if you have a quotient to a negative exponent, it's going to take the reciprocal and the exponent's going to become positive. If you need to understand what that is, go ahead and take a look at this. I can explain it in class, but I'm not going to take time during the video to explain this, but I will explain it in class once so that we can go over it and you can ask questions if you need to. But this is why it works. So if we have 3 over 4 to the negative third, we're going to take the reciprocal of 3/4 and the exponent becomes positive. Now all we have to do is do what we did here. So the 4 gets the 3, or the 4 gets to the third power, and the 3 gets to the third power. So it's 4 to the third over 3 to the third. All right? Well, 4 to the third is 64, 3 to the third is 27, so the final answer is 64 over 27. All right, last example. We have 7a over m to the negative second power. Again, do the reciprocal, turn the exponent positive, and then distribute the exponent of 2. So m to the second over 7a in parentheses to the second. All right, so m to the second is m to the second. And then here, just like we did quite a bit ago, we're going to distribute the exponent. So 7 to the second is 49, a to the second is a to the second. So the final answer is m to the second over 49 a to the second. All right, again, if you needed any help with any of the multiplication involving exponents, go back and watch the previous videos. Otherwise, ask me questions in class. All right, bye guys.